Now, because I don't know how to get into the code of your machines, I couldn't put these in the stat menu. So I put them in the program menu instead. So what you do is you push the button under stat, which is PRGM, program. Press that. Oops, yes, my battery's low. Yeah, you tell me for 2 days, and I'm going to keep ignoring it until it shuts off. Hopefully it makes it through the day. I've given you a bunch of stuff. The one we're going to be using right now, we'll use 3 of these in this class. I also gave you guys a few more for 244 and or 105 should you take either of those classes with me or with somebody else. They'll come in handy. I've got students at OSU still using these, which is great. So dist fill is the one you want to use right now. Why did I call it that? You'll see why momentarily. It's a strange title. I'm limited. I have 8 letters because this thing was made in 1982. Please.
Mine aren't showing up. I don't have that list.
Did you press program's empty? What the hell? Hang on 1 second there. Let's figure that out. I'll just come and share it again. Did you change your batteries between last? That is so strange. Yeah, go on there. Not a problem. We'll just reshare.
Can we not change our batteries?
No, you can, but if you change them while the computer's on, it'll erase the memory sometimes. That actually happened to me at 105 last week. Thank God I backed everything up on my computer. I was working with a student who had a really old PID 3 there. Welcome. And
make sure you turn it off and you replace it.
Right, and it got hung up. It hung on the transfer. So I was like, oh, I got this, and I pulled the battery. Then as soon as I did, I'm like, oh, damn, and then I put it back in, and it didn't erase it. I'm like, oh, sweet. And then it hung again the second time, and then I pulled it and it cleared the RAM. So all my programs were gone, which is okay because I back everything up. That's why I keep telling you guys, come to the office and I can hook up your machines and we can give you the stuff if you're, it's Friday afternoon, around. But you're welcome. That can result in erasing stuff if you're not ready for it. Oops. Beautiful. All right. So press program. Grab dist fill.
Thank you.
Yes. So it still works the rest of the day. Dist fill. Then press enter again. Now I wrote the program a little bit clunkily intentionally because you have to know what random variable you're actually testing. So it's the smallest x. So from class yesterday, what was x standing for? The number of female chickens we got in a certain flock. So you have to know what the smallest possible value for that number is. And what was it always? 0. Okay? Let's build flock 1. What's the largest number of females we can have? 1. Oh, we're going to go with flock 1 first, and we're going to work our way straight up just to get practice using the machine. Okay. 1 is the maximum number of females you can have. Pretty boring distribution if you remember correctly. Fairly boring. This one's right. Okay, press enter. At this point, if you stopped your program and went in and looked, I'll stop mine, you don't have to do it. If I stop my program and go in and look, at this point, the TI has cleared out all your lists and put the number 0 to 1 in L1. And at this point in the program, whatever you put 0 to blah, it'll put 0 to blah in L1. So just so you know, you don't have to stop anything, you can keep going. So let's just get out of here, start back up again. 0 to 1. This menu, ignore all of it except for binomial. I wrote this with a larger audience in mind, and I've since realized that the other 3 options are kind of dumb. So I just haven't gotten around to fixing it yet. So just pick binomial, because that's what most students use this for. And then you just have to put in the probability. And this is important. You have to know what that probability is. And you know what it is. Well, what do we use every single time yesterday? 90%, 0.9 as a decimal, otherwise it gets pissed. So 0.9 is a decimal. Enter. It's going to say done. It is quick, there's only 2. The only thing that has to fill it. It just filled L2 with 0.1 and 0.9, as you might remember from last class. And if you go back and look, stat, edit, there's the distribution we came up with. Now, you're not going to be very impressed by this, of course, because we did that in all of 30 seconds, and it took us longer to do it here. This program wasn't designed to do a 2 or 1 bird flock. It was designed to do a 41 bird flock. Yes. Yes, we'll come up to that eventually. So now, once you've got the distribution, you can see why it's called dist fill. You're filling up the distribution. What can you do with that distribution?
Spread bar 1.
Say that again.
Spread bar 1.
Yes! You can find its average and its standard deviation if you want to. And how do you do that? Just like you always have. One of our stats. Just run 1 bar stats. Stat, count, 1 var, make sure you put L1, L2. Don't forget that. A couple students in their class are still forgetting to put L1 and L2, and they're getting extraordinarily hopeful numbers for Vegas. This is saying I'm going to win 250 a game. That's correct, if you were rolling 1 die. L1, L2, there's your numbers if you need them. You're going to average 9/10 of a girl per flock. This, it depends on what you want to do. If you want to find the average, run 1 bar stats. See, essentially, what this program is doing, thank you for that question, Danielle. What this program is doing, you know all the times in this class when you guys have gone to stat, edit, and you filled in the distribution, L1 and L2? It's doing it for you. It's doing that step automatically. Then the next thing you always did after that step was you found the average of it. You still have to do that via any method you want. This is probably the easiest method. Or you found a standard deviation of it. But this is at least set the distribution up for you. Does that kind of make sense? If it doesn't make sense, it'll make more sense as we go through today. Ask me questions, Rach.
Excuse me, my 1 bar stats did not come up with that.
Did you do L1, L2?
Oh, no. Thanks.
It's okay. It's one of those non-intuitive things. If these things were set up better, they would automatically detect when you entered something in L2 and automatically queue it. Why don't they do it? They don't have to. We keep buying their crap. I mean, it's just one of those things. If I wrote the TI code, I would have it automatically. The 86 is like that. 86 is a far superior machine. How did they never get popular? I don't know. Why did Betamax never get popular back in the 80s? Why are Apples now finally getting the attention? I'm sorry, soapbox. Let's build flock number 2, shall we? Let's build flock number 2. So we're done with flock number 1. Flock number 1's boring. Flock number 2, back to program. Oh, please, John.
My comma won't work.
The comma won't work? Like it's stuck?
It gives me a J, but when I get out of
Oh!
it's
Alpha
Weird, yeah.
Did you spill like soda into it? Oh, here. That's it. No, you're fine. You don't need the comma. You just do that. Yeah. Now, if you want it to look just like this, I can make it look like this screen if you want. If you're happy with that, you don't need a comma. Okay, good. You're both. Keep guessing. And then L1, L2. Don't you worry, you're welcome. Let's build flock number 2. So disk fill number 3. This is when we bought 2 birds. Just run the program again, Richie. What's the least number of girls we can get with 2 birds? Still 0. Still 0. 0. Enter. What's the largest number we can get? 2. So right now, L1 goes 0, 1, 2. What's probability? It's binomial. That's pretty much the only one you're going to pick at this choice. You're pretty much always going to be pressing enter. There's your 0.9 again. That hasn't changed. That hasn't changed because of the independence of the trial. It's going to say done very rapidly. If you want at this point, you can go back and look at the numbers in the stat editor. Stat, edit, there's the distribution we came up with yesterday. I like this one in particular. I have fond memories of this one with you guys. Because a great discussion ensued right there. If I remember correctly, Nathan was the one that said it's going to be a boy and a girl and a boy. Or you said if either Bertha's a girl and Mary's a boy, or beautiful. And that's when we had the discussion of why is that, this was 0.1 times 0.1. This was 0.9 times 0.9. Why is that not just 0.9 times 0.1?
You have to add the other possibility.
Thank you, because there's another possibility. You could have this one be the girl or that one be the girl. So there were 2 instances of 0.9 times 0.1, which means there are 2 9%, which is 18%. Why is the program wonderful? You don't have to think about all of that anymore. We thought about it, exactly. We thought about that for an hour and a half on Tuesday. FYI, that was 5% of your class. And it was time well spent. It was time well spent because now you know you have to think about it. But knowing you have to think about it is kind of like knowing that you have to think about the spark plugs in your car firing when you step on the gas pedal. You just kind of trust they do. And when they don't, you get them worked on. Same thing here. You now know how the inner workings of this thing work. I don't have to torture you with that anymore. I want to focus more on, should you be upset? Should you be upset if you buy 2 birds and you get a boy and a girl? Should you be upset? Mathematically, are you allowed to be upset? I say no. I say no.
10 birds.
That's gonna, we'll come back to that. We're gonna have 41 birds. If you buy 2 birds and you get a boy and a girl, can you take it back to the store and demand a refund because you want egg-laying chickens? Not if the guy, well, you can. Okay. You can. Mathematically, do you have the right to? My vote is no. This happens pretty frequently. 18% is essentially 1 in 5, right? 1 in 5, which means out of every 5 times I send Max into the store to pick up 2 birds, on average, one of those times he's going to have a rooster in the box with a girl. That's pretty common, right? Sure, it's more common to have them both be girls. If you had 2 roosters, I might be a little pissed. 1 in 100, that's pretty rare, isn't it? That's pretty rare. 18%? Nah. No, I don't think it's that rare. That's my opinion. You have a different opinion. But as mathematically, 18% is not 1 in 5, right? 1 in 5. That's not all that low. In my opinion. In my opinion. You might not share that opinion, that's okay. Cool? Let's build the next flock. Flock number 3. Program. Oh, I didn't do the average. Is that okay? It's 1.8, isn't it? We knew that from yesterday. How do we know that from yesterday? We have good memories. How do we know it was 1.8? Do you remember?
2 times 90%.
Number of birds times the probability of a girl. 2 times 0.9. Remember, every time we added a bird to the flock, we added 0.9 more girls to the average? Every bird you buy is 90% female, mathematically speaking. So every time you add 1 bird, you're adding 0.9 of a female to your flock on average. So you got 2 birds, you got 1.8 females on average. Fair enough? You can run one of our stats, of course you can, by all means. I mean, run one of our stats on L1 and L2, and you'll see the average is 1.8. Yay! You also see your standard deviation. Yay, squared. But the idea is, with the binomial, and only with the binomial, you can do that little 2 times 0.9 and get the average automatically. That's what's gorgeous. One of the other gorgeous things about them. That is the most useful part of the binomial, FYI. We'll exploit that in Math 244. Let's do one more flock, take our 5, then come back and build our 4th flock. So we're at 3rd flock right now. So now we're into dist fill 0 up to 3. Boom, still binomial. And we're still, since we're drawing so few birds, we're still at 0.9. We're still at 0.9. We're happy with 0.9. I'll say done. I'll say done. And we could run the average, and you know what the average is going to be. 2.7 girls per 3 birds. Love it. But what I like doing is going into here. I like looking at those because I'm a little twisted. I like to ask the question, if you got that result, could you complain to the store?
Yes.
Yeah.
I would, honestly. If I brought 3 birds home and they all turned out to be roosters, I would go to the store and be like, dude, you told me there's a 90% shot that these are girls. I got 3 boys. And I would tell them there's basically no chance of that happening. And that's when he goes, oh crap, that's why they were so cheap. Or something along those lines. But essentially, you should not get, you should get it, what is that number? 0.001, which is 1 in 1,000. So if you send Max into the store to buy 3 birds 1,000 times, see, already, Val's laughing because that's ridiculous, the thought of that. But that's, on average, how many times it would take, and then you could roughly say, okay, I got 3 roosters over here, that's going to happen. But the chance of that being you going into the store is essentially 0 shall go.
Well, I mean, this might be a silly question.
No.
Does this take into consideration behavior of the
No! Not at all!
So
I'm
what
ignoring
if
that!
males cluster together?
Yes! I've thought about this a lot. We were supposed to get 4 more. I think I told you guys this. Our chickens have basically stopped laying, essentially. We're going to get 4 more. Day-olds came out last weekend, I believe, Friday of last week. Day-olds. They call day-olds. Like bagels. Like a bagel or a chick, whatever. So I'm sure they've gotten cleaned out by now. So we're getting the dregs. What's left, unless they get more day-olds, which I'm sure they will eventually at some point too. Are the girls act a different way, so you're more likely to grab a girl? Maybe they move around a lot more. Max, like his old man, looks for motion in Amphibian like me. Maybe he's going unconsciously towards the motion of the, I don't know, I have no answer for that, but I'm choosing to ignore it too.
Okay.
Is that okay? Because we're focusing on the mathematics, not so much much the research method. Natasha, go ahead. See, motion, that's what I saw, motion. So I don't know the answer to that. I'm choosing to ignore it to focus on the math. But that should not be ignored in general. That could be a source of bias in the sampling. Ooh, Math 244. Bias in the sampling can happen. It happened yesterday in 105. But for 105, a couple of you guys in 105. None of you. Like I said, I had none of you in 105. There's a problem I do called the Monty Hall problem, where I built a set of doors. Monty Hall, let's make a deal. Wayne Brady, let's make a deal. Sorry, Wayne Brady, let's make a deal. Back in the 70s with Monty Hall. 3 doors. You pick a door. There's a prize behind one of them. Monty opens an empty door and says, look, there's nothing behind that door. And then he offers you the chance to switch or to stay with your original door. And I always love asking the class, what should you do? And I don't tell them the answer right away because I'm a bastard. And we simulate it using my doors and lollipops hundreds of times. Right? Hundreds of times. And I try so carefully not to give little hints away. What I'm doing, I duck behind the doors and I hide a lollipop behind the doors. Well, students tell me, when I was hiding it behind door number 2, I would always come up like this. They figured that out. You guys are so freaking perceptive, it's terrifying. And they say when I was going to open the door, I was playing Monty, my eyes always went to where the lollipop was. And I didn't realize I was doing that. So yesterday, I brought sunglasses. I would hide the lollipop down low and then walk outside, say pick your door, put the glasses back on, walk back in, trying to mitigate everything. Then I was reacting to their responses. At one point, one girl always switched. I was like, Cassie, why are you always switching? Shit, why did I say that? Because as soon as you comment on the behavior of a system, the system is going to change. So I don't know the answer to that, but it's a very valuable psychological question, which I can't answer. Eh? I mean, it's a long-winded answer for no answer. But I guess what I'm telling you is you should mark that. I just don't know how to mark that. And it gets away from what we're doing right here. How about if I got 1 girl and 2 boys? Gonna be pissed there? Well, Sarah's saying, and we're getting kind of into that region. 2.7% is pretty rare. There's a universal definition that says anything below 5% is pretty unusual. You should count that as dependable. So that's getting under that. How about if I got 2 girls and a boy? Are you ready to be pissed? No, that's 25% of the time. Look, 243 like your class.
Shouldn't be happy.
Well, I'm not saying happy. You have no right to complain. I mean, you know, I'm not happy about Congress either. But I'm not sure if I have a right to complain about them, right? I mean, I voted some of them in. So, the point, oh, it's off. I'm going to leave it off so the batteries recharge. But the point is that with 24.3% likelihood, I think we had this discussion yesterday. I asked how many of you have one other sibling. And we saw that it happens all the time. You end up getting flip-flop back roughly 25% of the time. 25% is not rare enough to be weird. Now, does anybody here have 5 other siblings? And they're all the same gender as you? Then we start looking at your parents' genes. And maybe your parents are just predisposed to having one gender for whatever reason. I don't know. And I won't do that, I promise, because that's like a lawsuit waiting to happen. So, let's take 5. We're 5 past our 5. Shit means we're at 0. Let's take 5. Other questions? Let me turn the camera off. What's up, Danielle? We're going to do your flock soon, I promise.